Hi, I'm Philip, and in this video I will look at the accuracy of the newly released Creality Sermoon P1. I will especially look at the accuracy in laser mode. For the scan setup, I use a micrometer to test the accuracy, and the micrometer itself is placed on a turntable. And I use marker geometries to allow scans with more shallow angles, so I can properly scan the faces that I use to measure the distance, so the spindle and the anvil. If you already know this part of my mythology and may have looked at other videos, you can just skip to the final results. I have put timestamps in the video. The marker geometries are also linked in the video description, and they could just help you with proper scanning. I 3D printed mine with a SLS printer, but you can just use any FDM printer or just buy finished marker geometries. While scanning, I also didn't rotate the turntable simply to prevent inducing wobble or inducing movement into the micrometer, because as you can see on the micrometer itself, I don't have any markers, so only the turntable and the marker geometries are tracked. I also use scan spray. So to start with, I always calibrate the micrometer to 125.00 millimeter plus minus 0.01 millimeter with a calibration rod for the micrometer. And the anvil and spindle are polished to a mirror finish. So this is just like some carbide inserts, and to properly scan them, I need to use scan spray on both. And for this, I just use a thin coat of Esa Blue. So it's the Esa Blue branded scan spray. And per manufacturer's spec, it's like the thickness is between 8 and 550 micrometers. So I just use calculate with 8 micrometers per side. So the final target or the final nominal is 124.984 millimeters. For the scan settings, you may see here the laser and IR mode, but I will focus on the laser mode. So in laser, I set the target point distance to 0.2 millimeters, and I scan until the target quality is reached. So the scanning software shows me full coverage of the data. And I fuse and mesh at the default recommended settings, which are in this case also 0.2 millimeters. And I repeat this measurement 6 times, and I now see there's a typo, I'm sorry. For the IR scan, currently it is not possible since marker tracking isn't supported yet. I guess this will be released with a next firmware version. So the field to select marker tracking IO mode is already there, but grayed out. So maybe this is due to the fact that I received the scanner a bit earlier for testing. So I guess, it will be added with firmware updates. Now for the scan results, you can see here, these are the 6 repetitions in quick surface. And for my measurement process, I just import the scan files from the scanner into quick surface, and then I extract planes on anvil and spindle as primitives. So I always try to start with the spindle here. You can see in quick surface, I just can use the extract primitive tool, click on the face, and it basically creates me a plane trying to fit the data as close as possible. And both planes, so when I create the second plane, it is constrained to be parallel to the first plane, so proper measurement between the planes is possible. And then I just measure the distance between the planes. Now let's look at the stated accuracy of the Sermoon P1 as the manufacturer specs. So we are here in the volumetric accuracy it is 0.2 millimeters plus minus 0.06 millimeters. And for the 125 millimeters of distance, for the micrometer we measure, we come out to 0.0275 millimeters. Now let's look at the scan results. So we have the nominal, so it's the micrometer phase of 124.984 millimeters plus minus 0.01 millimeters. These are the values measured. Don't worry, I will show you a table shortly, so they get a bit more of meaning. The mean value of all 6 measurements is 124.976 millimeters, and the delta mean is minus 0.008 millimeters. so the delta mean compared to the nominal. So with a spec given of 0.0275 millimeters, this is a very respectable value. I hope I can also add the IR scan in the near future when the firmware update comes out, but I just wanted to publish the results now. And now let's look at the table. Now let's have a look at the table. It's a bit crowded, I'm very sorry. I'm still a bit uncertain if I want to keep values of different scanners, but for this time I want to keep it. So in this dark blue color, we have the nominal, so our target. And here in this thick lila line, we have the Sermoon P1. We have a delta mean of 0.008 millimeters. And we also have other entries for the MetroY Pro in laser mode, the Einstar Rockit in laser mode, and the Sermoon S1 laser mode. And I also can spoil a bit. I will shortly add the Revopoint Rockit and the Einscan Rigil to these comparisons, to stay tuned. So with the result, I'm very happy. You can see there's a bit of a spread, so the delta mean may look a bit better than the line. But I hope you enjoyed, and stay tuned for the next accuracy specs or comparisons.